Understand AI in your world. This lesson describes what AI is and how it works through concepts such as machine learning (ML) and generative AI (GenAI). You'll discover how AI is woven into everyday experiences and investigate its potential to transform education. Plus, key applications are presented as examples of how AI can create a more inclusive learning environment and empower all students to succeed. AI fundamentals and inner workings. As you've learned, AI describes computer programs that complete cognitive tasks, typically associated with human intelligence. A cognitive task is any mental activity, such as thinking, understanding, learning, and remembering. Cognitive abilities enable people to make effective choices and thoughtfully solve problems, yet there are limits to how much information humans can process. This is where AI comes in, extending our information processing skills, supporting creativity and innovation, and expediting routine tasks. The AI for K-12 initiative is a joint effort by the Association for the Advancement of Artificial Intelligence and the Computer Science Teachers Association, which is focused on developing national guidelines for teaching AI in K-12 classrooms. The initiative identifies 5 big ideas in artificial intelligence that describe the fundamental concepts in the field. Perception refers to AI's ability to receive and interpret information through computer vision, speech recognition, and other sensor-based inputs. Before moving on, take a moment to explore machine learning (ML) a bit more in depth. Machine learning refers to the process of a machine learning. Think of it like training a pet. You toss your dog a ball and say, "Fetch." Then you reward her when she brings it back. Over time, she learns to associate fetch with the action, even if you use a different ball or toy. ML algorithms are similar. They learn from examples and improve their ability to identify patterns as they're exposed to more information. Put simply, an algorithm is a set of rules that a computer follows to solve problems. So, like a dog playing fetch, ML is used to develop computer programs that can analyze data to make decisions or predictions, without needing explicit instructions for every single situation. Many AI tools use ML for tasks that require flexibility and adaptability. A common example is spam filtering in email programs, where ML algorithms can identify patterns typical of spam messages, such as an unusual amount of typos. But here's the twist. ML goes beyond simple rules. The program is also trained to recognize patterns in your usual email traffic, so it won't mistakenly send an email from a friend or colleague with a few typos straight to spam. It learns what's normal for you and what's not, just like your dog learns the difference between a dog toy and your favorite pair of shoes. Understanding the different types of ML and how they support AI will enable you to use AI tools even more effectively. There are 3 common approaches to training ML programs: supervised learning, unsupervised learning, and reinforcement learning. Click each tab to reveal more information and to move forward. Supervised learning is a type of ML that uses labeled datasets to train a program to recognize patterns in data. Labeled data is like flashcards for machine learning models. In a standard flashcard, you might have a question on one side and answer on the other. The supervised learning flashcard would be data question on one side, label answer on the other. An example of a labeled dataset that a teacher might use is a dataset of quiz questions labeled according to difficulty. A supervised machine learning program could use that labeled dataset to analyze a student's performance in math class over time. GenAI often uses a combination of supervised, unsupervised, and reinforcement learning, and all 3 approaches play distinct roles in conversational AI tools, which adapt to conversational context. understand human language requests, engage in natural dialogue, and generate responses in a meaningful way. Here's how the 3 types of ML support conversational AI. Supervised learning equips the tools with foundational dialogue data, enabling them to respond appropriately to common communicative cues. Unsupervised learning enables them to interpret nuances in language, such as colloquialisms, that occur naturally in conversation. Reinforcement learning further strengthens them by allowing the AI tools to improve their responses based on user feedback. Note that for the purposes of this course, conversational AI tools will be referred to as simply an AI tool. ML advancements help pave the way for generative AI, GenAI, AI that can generate new content, such as text, images, or other media. The influence of GenAI also extends to a wide range of diverse sectors, including drug research and discovery, industrial design, architecture, and fashion. For instance, by generating novel molecule structures, GenAI can speed the development of life-saving medications. It empowers the creation of unique product variations and visionary building concepts. Further, designers can tap into GenAI to inspire one-of-a-kind patterns and personalize clothing for the perfect fit. Now, discover more about how ML makes AI tools possible. Consider these examples. Click each image to reveal more information and to move forward. Right on your smartphone, a voice-activated AI assistant can set reminders and integrate with your smart devices. To do this, the assistant uses supervised learning models trained on labeled data, such as voice commands paired with corresponding actions. Navigation tools use AI to analyze traffic data and suggest optimal routes, predict arrival times, and identify road closures. This is a combination of supervised and unsupervised learning. Supervised learning helps predict the best possible drive using real-time traffic data. Meanwhile, unsupervised learning identifies unusual and recurring traffic patterns. As you continue learning about AI, you'll understand more about why AI requires human involvement to function properly. For example, ML programs can't learn independently. They need people to continually update their training. Also, shortcomings in training data can reflect or amplify biases, leading to skewed or unfair outcomes. And of course, there are many tasks that require a personal touch, such as handling sensitive issues. You'll explore these issues more in depth soon. For now, just understand that critical evaluation is essential to address potential challenges and limitations. It can be challenging to distinguish AI tools from non-AI tools. The following is a simple breakdown to keep in mind and help you more easily differentiate the two. Click each tab to reveal more information and to move forward. Here's a quick activity to review a key concept from this lesson. You've learned about some key distinctions between AI and non-AI systems. Now, sort each of the following into the appropriate category. Drag each text box to the correct drop zone to move forward. The text box will return to its original position if it is dropped in the incorrect drop zone.